Hey everybody, welcome back. Working in Savas Algebra 2, lesson 7-3, but doing a review problem that goes back to the statistics unit. So hopefully you don't forget the things we've learned previously in the course. We have a set of data that describe, and we're supposed to describe the shape. Remember, skewed left, skewed right, normal. And sometimes I think those are a little difficult to tell. They seem kind of close sometimes. So we'll see what we have here. Shape, the distribution, and determine which measure of center. Remember, if it's normal, we're going to use the mean. If it's not, if it's skewed to one side or the other, we'll use the median, because if it's skewed, the outliers that are way off on one side or the other pull your mean too far in that direction. So like if we had a skewed left, remember it's the tailing off side that gets the name skewed left in this case. But these out here are going to take your mean and they're going to pull it over this way because you're going to have some real small numbers compared to what the average normal is in the group. So we would not use the mean because the mean is going to be over here, and the median over here is actually going to show us a better center of all of our data, or average, if you will. So the distribution is, I took all this data and took the liberty of putting it into decimals. I'll show you that. And our choices are, is it approximately normal, noticeably skewed left, approximately uniform, that's like even all across the board, or skewed right. And so noticeably being a kind of key word here. So I came over here, let me take those drawings off. I came over here, and when I looked at, let me double check that you're seeing what, okay, you're seeing what I'm seeing. When I looked at this, the box plot, so up here at the top, type in my list of data, letter L I used, and then square bracket, all of the data separated by commas. If I want to make a box plot, let me turn one of these maybe off. Sometimes I think it feels a little confusing. I don't know if I can't quite get a hold of that. Well, I'll leave them both on, I guess. Let's say this toolbar. This toolbar is in my way. I turn that histogram off. The box plot, from the median, the vertical bar in the middle, to the minimum over on the far left, and you've got a little bit of more distance on that left side there. And then if we again, if we look at the box plot again, there's that one high bar with just two responses on the far right. But really, this feels kind of uniform. They're just across the board, the one response everywhere. So I feel like it could be that it's uniform. I think most likely it feels to me uniform. So just looking at that, the distribution, I would call it uniform, approximately uniform. And so if it's uniform, that means the only time we really worry about the median is when we have the skewed data. And if we looked for the mean here, this could be that it doesn't like what I want. It wanted us to say the skewed left, but we just type in the mean and an L, and it'll calculate it for me, so I don't have to go through all that. So 42.857, 42.857, and they went to the nearest 10th. 42.85 would be 42.9. I know some of you sometimes it won't let us check the answer right now until we put everything in. So again, to the nearest 10th, that was 42.85, so 42.9, 42.9. And if it's the mean, then we're going to use the standard deviation. And if we want the standard deviation in Desmos, if it's a population or a sample, which they don't say this is our whole set. So then you use the standard deviation of the population. Standard deviation of the population. So use that P. And if we do that, and again, it wanted us to the 10th. So if we go to the 10th, 15.7. I don't know, I have a mixed feeling about this, that it's going to say one of them more. See, use the mean, median, or mode here. And at least one of the answers is incorrect. Plot a histogram, compare it to these shapes. It definitely, to me, seems mostly uniform. So I really feel that uniform is right. And if it is uniform, let's see, if we view an example, what they're going to say here, the shape can be determined, continue. This one looks like it's going to be more normal though. So like if this one says the shape is more like this normal, and when based on the information, it's normal, yep. And then for approximately normal, you use the mean and the standard deviation. So technology, they found it, they rounded it, technology. So when we look at ours, that definitely has a look of normal. And we've got the standard deviation at 15.7 and the mean at 42.9. And so if we're using that, I mean, we could go back in here and say, choose the median. And if you want to do the median, that shows up if you do a stats of L. That actually gives you your 5-number summary, your box and whisker plot. So the median at 43, I don't think it's going to like that. I mean, it's pretty much the same what we just had anyway, 43. And then instead of the standard deviation here, you use the interquartile range. And your interquartile range, you subtract your quartile, upper quartile Q3, 54, minus your lower quartile Q1. So you have a 20, but I am just not really feeling that's what it's after. So I'm kind of wondering, actually, if they want us to go back here and say, well, it is, when you look at that box and whisker plot, let's go back to that. Get that out of your way. Looking at the box and whisker plot. It is slightly skewed left, but sure, if you look from the median here to the left and the median to the right, there's not that much difference in the length of those. So if it did want us to say it was slightly, it's not noticeable. So if we're using the other two, approximately uniform and the median at 43 in the interquartile range, what did they want? They said they wanted normal. We had that. We did our mean and we did our standard deviation. So I thought we had that as an answer once, but it did not do it. So let's try one more time. I thought that's what I put in, the normal, mean when we did it, 42.9, and the standard deviation when I did that, 15 of the population, 15.7. Oh, I thought I typed that as an answer. All right, so I'm gonna have you guys pause for a moment while I enter the data for the next example. But I showed you those, how to do that, and let me stop this, pause the recording, and I'll be right back. All right, everybody, let's take another shot at this bad boy here. Cell, new set of data. I've entered the new data, the 29, 12, 24, 35, 57, 39, 45, 68, 47, 34, 52, 57, 66, 47 into my list, L. I've got a box plot and a histogram if you want to see those. So this one still feels to me not hugely, but if you look at this, somebody might say it's skewed left, but I'm going to still say we're looking more at a normal, approximately uniform. And so if it's uniform, that we're going to still go ahead and use our mean. And our mean of this data, 47 or 43.7, 43.7. And then if it's the mean, we're going to go ahead and use the standard deviation. And this was our whole data set, so we used the population standard deviation of 15.4. And so the 15.4, and check it, it didn't like that. So I feel like I want to take a screenshot this time to have evidence that that's what I typed in. Thought I did that on one of the last ones. And so if it's not approximately uniform and we're using the mean and standard deviation, it could be slightly skewed left, of which case we would use the median. And in our median here, stats, it's at 46. And if we're doing the median, we use the interquartile range and subtract Q3, 57 minus Q1, 34, 57 minus 34, be about 23, yeah, 23. And use that. But we tried this last time and it still didn't like it. So again, if I view an example, but their example has a normal distribution, not one that shows the other. So I still think we could call it normal with the mean, but I don't think this is what it wants either. I thought it was uniform when we looked at this. This looks more flat across the board. We've got 2 bars here in the middle, but let's just put it in. And then this is the last one I'm going to waste your time on. Again, what was the mean here? The mean, 43.7. It said 1 decimal, right? Nearest 10th, 43.7. And if you're using the mean, use the standard deviation. And for my standard deviation, use the population, unless it says it's a sample of data, 15.4. So again, I think that's what I had in this first time I put in, though. Approximately normal, a mean 43.7, a standard deviation of 15.4, but I'm gonna get it wrong. I think that's exactly what I typed in the other time, and it said it wasn't right. So I don't know. Good luck, everybody. Sometimes the numbers, it seems like you do one thing and get it right. Next time, do the same thing, get it wrong. But I think there's just a Savas thing going on there, or I wasn't paying as close attention, even though I took a snapshot of it because I thought I want to compare it. And I believe that's exactly what I have from the first time. Approximately normal, mean 43.7, standard deviation 15. Sometimes I just don't really get Savas what they do. So good luck, everybody. Stick with it like I did there, and it says it'll be right.